Welcome to the review part 2 of graphing and writing sine and cosine. So we're going to go and get started on this one. This is our cosine, it's the cosine curve, and again this does have a period change. We'll do this one a little bit different, so we get 2 pi over 2 just like normal. But what we're going to do is when we graph this, we're only going to graph one period of the function for a mini function. And of course pi is 6 pi over 6, right? So that means I have to go over 6 tick marks. 1, 2, 3, 4, 5, 6 before it starts to repeat itself. Now cosine, remember the pattern, starts high at 1, right? And normally cosine ends at 2 pi at 1. But we're only doing half it. See, the normal period for cosine is 2 pi. We're doing half of that. So instead of being up here, we're going to end up here at 1, at pi. Now, cosine is normally negative 1 at pi. But again, we're doing half of that. So at pi over 2 is where we put our negative 1. And there we have one period of our cosine curve. So, once we get the one period here, we can actually graph our transformations. The amplitude here is 1, so that's not going to affect anything. We do have a phase shift. We do the opposite if it's on the inside. So this says to go left pi over 3. But remember, to get pi over 3, each tick mark is pi over 6, so it's pi over 6, 2 pi over 6. So we have to go left 2 little tick marks there. Our vertical shift, +1, that means we're going to go up like a disco duck. So when I graph my transformations here, very easy. We start with the phase shift. This says to go left 2 ticks, and then it says to go up 1. So if I go left 2 from here, 1, 2, up 1, be careful of scaling. Each one of these is, we have to go up 2 to go for 1, so up left 1, 2, up 1, left 2, up 1, left 2, up 1, and we have our very first transformation, our very first period. Now, we can't leave our graph like this. We have to complete all the way through. And I know there's a lot of Aggie fans out there that will be disappointed. Hook 'em horns. Okay? But we have to continue with the pattern. So, it's not that bad if you remember how it repeats. If you know the period, I know it's going to be back up top at pi. Every pi. 1, 2, 3, 4, 5, 6. When is it going to be at the top again? 6 later. 1, 2, 3, 4, 5, 6. Do it the other way. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. We can't finish that one up here, but we'll talk about what we do there. Down here, same thing. When's it going to be at the bottom? At pi units. Very good. So we count over 6. 1, 2, 3, 4, 5, 6. Go the other way. 1, 2, 3, 4, 5, 6. Keep going. 1, 2, 3, 4, 5, 6. Exciting, I know. And we just continue the pattern. Now take a look. I didn't stop there. I know it goes down, so I draw it going down. Continue on. Oh, there it is, the Warnock function. It's everywhere. And I continue the pattern, and this time it's going to go up like a disco duck. And there's our graph. And you can get your domain, negative infinity to positive infinity, our range 0 to 1, 2. All right. So let's review some writing equations, okay? So let's take a look here on the back. And we'll take a look at some examples of writing equations. So remember to write the equations. We wanted to get this in the form of y equals a cosine b theta minus c plus d. So we got to take a look here. Now the easiest way to do it, get your period first. Okay, we always deal with the period, and that's easy to do. We're going to count from peak to peak. That's our period of our function. I just count that distance. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12 pi over 6s, or 2 pi. Oh, that's nice. So my period is 2 pi. And we can get b by saying 2 pi over b equals our period 2 pi over 1. So, we got b already. b is 1. Okay. To get the amplitude, To get A is the amplitude, right? A is my amplitude. To get that, I'm going to draw my midline. Now this is kind of nice for us. I drew the dots for you because I like it. There is my midline. Okay? There's our midline. Now, depending on how you're going to scale this, we can call that a half. Okay? But let's call this 1 instead. Normally we'll always tell you, let that be 1. Okay? Makes it easier for us. So the amplitude, remember, is the distance from the peak to the midline. And in this case, if we scale by 1, A is 1. Okay? There. And that's kind of nice for us because the midline also gives us D. D is the midline. Okay? So, nice thing about finding the midline, it gives us 2. So we don't have to have a midline crisis. Okay? So, now, our midline then, D, is just, 1. It's y equals 1. There's my midline. And now the last part that we have to take a look at, we have A, we have D, we have B, we're missing C. Now, C is our phase shift. Now, remember, in trig, shift happens. So we have to be very careful. The phase shift, recall, is our distance from the y-axis to a peak for cosine. So we count over 1, 2, 3, 4, 5. So that's going to be 5 pi over 6. So my equation then for cosine will be y equals A, which was 1, cosine B, which is 1, theta minus C, which is 5 pi over 6, plus 1. Oh, our amplitude there. Oh, I messed up. Our amplitude was 2. How weird was that? Sorry. So let's go back and fix that. Our amplitude was 2. Because remember, I'm scaling by 1s there. So be careful. Some of you guys probably caught that. I'm going to hear about that tomorrow, I'm sure. So the cosine, so the amplitude there should be 2. So yes, we did fix that. So to get the sine value, it's the same thing. Everything is the same. Theta minus, the only thing that differs is our C value. So for sine of theta, our C, remember, normally we start in the middle, sine goes up, go to your midline, go to what happens. There it is. Count over, 1, 2. That's 2 pi over 6 or pi over 3. And there we have our function. Alright, let's take a look at one more example. I like to call this le Mustache the Frenchman. Okay, so same idea. We have to find the period here. So to get the period of this function, that's going to help give us B. I count from peak to peak. Now I'm going to kind of cheat a little bit because I'm going to tell you this is supposed to go over 24 pi over 6. So this is my period, and counting ahead, count over, I think, 24 ticks, we get 24 pi over 6, or 4 pi. So we have a very long period here. Okay? So, to get B, so the period is 4 pi. To get B, we're going to take that 4 pi, set that equal to 2 pi over B. Cross multiply, the B's don't matter any. So you get 4B equals 2, so B is 1/2. To get A, we're going to look at the amplitude. So I draw my midline. So I take a look at kind of what's in the middle there. Ooh, interesting one here. To get our midline, I have to go in the middle here. There's my midline. That's an interesting one. Okay? So our amplitude is the distance between. So again, let's scale by 1s. So my amplitude, my A, is going to be also, looks like 1/2. Or 3/2. It doesn't matter which one you pick. To get D then, that's our midline. And our midline is at 1/2. It's the equation y equals 1/2. So that's D. D becomes 1/2. Oh, look, a lot of fraction on this one. And now to get C, that's our phase shift. Okay? For cosine, and you can write them both at the same time here, and for sine. Sometimes people like to write it this way. For cosine, C, I count to the peak from the y-axis, 1 pi over 6. There it is. For sine, we normally start going up, so I take a look here. Now, if I count to the right, I never see it going up. So in this case, I'm going to count to the left. 1, 2, 3, 4. There it is at 4. So it's negative 4 pi over 6 or negative 2 pi over 3. That's our C value for sine. So I can write my two equations now. Y equals, for cosine, 1/2 cosine, whoops, that should be 3/2 A, cosine B, which is 1/2 theta minus pi over 6 plus 1/2. Yuck. And for sine, y equals 3/2 sine 1/2, and we get theta plus, we change our sign, 2 pi over 3 plus 1/2. Alright, and there we have our review. Alright, so tomorrow you'll be working on review questions, and don't forget you also have a quiz on graphing these. So if you need to, go back and look at the videos, work some more problems. Okay, and we'll see you guys tomorrow. Thank you.